okay, in the x direction. So in the x direction, what happened is that the idea is that what's the idea here is to recognize that, let's take, for example, 2, all right? And what we said is that in 2, the magnetic field is in this direction, okay? And since I'm asking for the x component, then the magnetic in the x direction, then the x direction should be is like this here. That's the x component of the magnetic field. But now, if I choose another one, okay, let's say on this side here, all right, then the magnetic field on this side, this is going to be my R, sorry, this is going to be my R, if you remember, this is my R, okay, and so up, so B is up, so my magnetic field for this one will be in that direction. And what's the x component is going to be, that's my x component. Are you guys all following? So what the idea is to recognize that for each 2, I'm going to have, let's say, another on the other side, which is going to give me a magnetic field which is equal and opposite direction on the x direction. Is this clear to everyone? So this is, let me write this here. So this is, wait. So this is the magnetic field B2. Okay. Now, this is another wire here. I'm going to say 2 prime. And that's my magnetic field B of 2 prime. Okay. And here is the magnetic field BX of 2 prime, caused by 2 prime. And here BX caused by 2. Okay, everyone? Consequently, for each 2, I'm going to have a 2 prime. If I change 2 between 1 and L, then I'm going to have the total contribution should be equal and opposite to the one which goes from 1 to the left of the sheet. Okay. Consequently, is this clear? These because I have to move downward. Is this clear for everyone? Actually, I can leave it a little bit. Give me a second. Yes, okay, I'm here, thank you. Okay, so I'm gonna, wait. So I'm gonna go down. Okay, so here what I should write, what I could write is that here, for each element wire giving say a positive B in the x direction, there is an element wire giving a negative B in the x direction, as illustrated in the figure, if you want. Okay, for this reason, consequently, Bx total, T total, is equal to 0. Because for each B positive, I'm going to have a B which is negative. Okay? Okay. I hope this is okay. Now I continue. Now, what is shown show that B in the y direction at P, at the point P, which is in the middle of the sheet, okay, is equal to mu0 J divided by 2. I don't remember, probably there was a mistake here somewhere. Let me double check. Okay, so let me first get rid of this. Okay, now I'm going to get rid of this. I'm going to get rid of that. I'm going to get rid of this, and I'm going to do that. Okay, so I'm going to have B of 2 and B of 2 prime. Now, how was the B2Y in the y direction? I remind you, let me say, this is the x direction, and that's my y direction. Okay, so okay, so in this case, B2 and B2 prime, they always give they have the y component in the same direction. Okay, consequently, what I need to do here, I need to say that my B2Y, By, the magnetic field in the y direction, okay, adds up, okay, for all the element wires, for all the element wires, okay. If they add up, then By is going to be equal to integration from minus a over 2 to plus a over 2 of B, I'm going to put a parenthesis wire for one wire, okay, dy. Okay. Now, what was my B wire? So By is equal to integral from minus a over 2 to plus a over 2. What was B? I need to go back. A over 2. I need to go back. Sorry about that. What did I obtain? I need to remember. It was mu0 I divided by 2 pi r, right? Okay. So this was of mu0 I, okay, divided by r, which was basically y, or I don't know how that divided by 2 pi x. Okay, if I'm not mistaken, let's see what I call this thing, xp. Yes, I'm still at xp. Yes. Okay. Where am I? Okay, all this now gets out. All this now gets out. So basically, I'm going to have B equal to mu0 I 2 pi x. What was the question? Yeah. J. Okay. mu0 J divided by 2. Let me see. So then I need to integrate, but I don't know how to get the pi gets out of here. So all this gets out. This is all constant. Okay, dy, and dy is minus a over 2 to plus a over 2, so it's equal to a. And now I'm going to have j is equal to I divided by delta divided by A multiplied by delta. You replace all this and you end up having mu 0 j divided, but there's an issue, then I don't know how to get rid of the pi. But basically that's the bottom idea, okay? The bottom idea is to replace this one by its value, and no, wait. Yes, wait. Your x, what's x? Okay, I understand what the issue is. What's x? Let me go back here, okay? This is the x. What's x? X is the distance between the source and the point of space where you're calculating it, okay? Consequently, your x is this distance here. I'm gonna draw it from 2. That's your x. So you have to put, this is your x. So your x, you have to put it as a function of xp and y, okay? For example, you can write down that x is equal to square root of xp squared plus y squared, or you can plot it as a function of theta, and then you integrate the two. Do you understand? When I say mu 0x, when I calculated for one wire, okay? And for one wire, the R is equal to xp. مظبوط؟ لأنه R is where the Amperian loop is, okay, which passes by P. So R is the same as xp, okay? Now, if I calculate it for 2 or for 2 prime, R is the distance between this point here and the point P, okay? And for this reason, you have to write this distance R as function of xp, because that's where you want to calculate it, and as function of y. Consequently, now your x, for example, here that you can see here, does depend on y, and you have to integrate it over y to get the final answer. Capish or no capish? The issue is that, so here, the problem is that, so mu 0I divided by 2 pi x, but now you have to integrate, and this is dy, okay? And then you have to integrate over the values of y, because now x depends on y, okay? Is this clear? Tamar?
Yes, it's clear.
But you still need to do the mathematics at home, okay? Continue the mathematics. It's not done 100%, okay? So I highly recommend that you guys continue the work that you're doing here at home, so you can get the full calculations. Okay. Now let's continue with our and now. For a current that's caused by time-changing n of t, showed that at point P, the ratio between the electric field and does not depend on the shape of the sheet, and comment on the proportionality constant. So basically now, remember at the beginning of this exercise, we charged this sheet by removing some number n of charges. Okay, so on the idea is to have, now my number n is time dependent, okay? Consequently, if n is time dependent, this means that my I equal to dn over dt is time dependent, right? If my I is time dependent, then B, the one that mu 0 j, that even if you can take it from here, j is 1 over a I. Right? So here B is equal to mu 0 I over A over 2A. If I is time dependent, if N is time dependent, I is time dependent, B is time dependent. So from this equation, B equal to mu 0 J divided by 2, I'm going to have the dependence of B on I. And then I can use Gauss's law. E is equal to sigma over epsilon 0, right? So V, I'm going to write down. So I'm going to have B equal to mu 0 I over 2A. Okay? Now I is equal, or I is equal to dq over dt, which is equal to small e, the elementary charge, dn over dt. Okay? Now, how about the electric field? The current, the relationship between the electric field and the magnetic field. That's what we need to find. Okay? The electric field E is equal to sigma, right? Divided by 2 epsilon 0. What's sigma? Sigma is equal to Q over A, right? Over A. Yes, over A. Of course, everything is 2 epsilon 0. Okay. Consequently, if I take the time derivative of E, now let me write it as equal to small e multiplied by n, that's my total charge, E multiplied by n, divided by the area A divided by 2 and epsilon 0. Now, if I take the time derivative of E, of the electric field. Okay, in this case, we are going to have dE over dt is equal to, E is constant, the area is constant, epsilon 0 is constant, so I'm going to have E over 2A epsilon 0 multiplied by dN over dt. Right? But what is dN over dt? dN over dt is, I can write it in terms of B, right? So this is equal to E over 2A epsilon 0 multiplied by dN over dt. dN over dt هي 1 over E. Okay? 1 over E. So basically, if I go back here, so this gives me B, this gives me B is equal to mu 0 over 2A multiplied by I, which is E multiplied by dN over dt. Okay? So from here, I can get dN over dt. So dN over dt, let me space it a little bit.
سر مش لازم نقسم سيجما اوفر 2 ابسلون 0 على الاريا تاعت الجاوسيان سيرفيس اللي اخدنا منها ايه؟
لا هون لا حبيبي هون. In order to determine the electric field, we use the Gauss surface. خلاص. بس هون A sigma is the actual real charge density. So it's the total charge divided by the total area of the sheet. بخاصة بقى بالجاوس surface. It's some arbitrary surface. Is this clear to everyone?
حكيتك عم تستعمل جاوس's law ما انتبهت لسيجما.
لا I'm using I already used Gauss's law to get the ratio between E and the charge.
I understand.
Okay. Everyone is on the same page ولا صعب يا شباب؟ This is supposed to be a difficult question in the exam. Okay. So dN over dt is equal to mu 0 over 2A E multiplied by B. Dn, no, it's B sorry, it's B multiplied by 2EA divided by mu0. Okay? Everyone's following? So then now, so what did I write here? Where is that? So then this is equal to E over 2A epsilon 2A epsilon 0 multiplied by dn over dt. dn dt B, so I need to multiply it by B, multiplied by E, so I have E squared, multiplied by the area A, divided by epsilon 0, and divided by here by mu 0. Now, the idea is that the 2A, do I have a 2 somewhere? I have a 2, yes. E squared, okay, and I'm going to have a 2 here, 2A, and here I used to have 2A. The 2A will go away, and this 2A will go away. And you can clearly see that the relationship between the dE over dt is equal to B multiplied by E squared. If I'm not mistaken, probably there's if I'm not mistaken.
Professor?
Yes?
I think dn over dt should be equal to B2A over E mu 0.
مظبوط, E should be in the denominator, you're right.
Yeah.
The denominator, that's why it should not be appear here. That's right. Yeah. This should go away. So this is B. E should be in the denominator. So here E. Right? مظبوط الشغل?
Yeah.
That's right. Thank you. Okay, sigma over 2 epsilon 0. Okay, this is all correct. So then now clearly you can see that the relationship between the electric field, time variation, and the magnetic field, there's only one thing, which is the proportionality constant. Do you have an idea about the proportionality constant? Guys, what is the proportionality constant? Do you know? The proportionality constant is actually
Is it K?
the speed of light.
C.
Is E is equal to C squared. The speed of light. Yeah. So that was the tough part of this problem, of this exam. This was the exam. Okay. Okay, guys. I'm going to leave you there. Please continue doing this problem here. Should be straightforward, and we'll discuss it next time. Okay.
Sir,
Yes.
yeah, is it gonna be?
Go ahead.
It's not gonna be an MCQ. How are we gonna show our work on Moodle?
No. It's going to be. I'm gonna give you a place where you can download. So you're gonna solve, and you're gonna download them in a folder. Okay. And I'll try to correct them.
Wait, sir, but there's no Faraday in the exam, right?
Yes, I'm not gonna put Faraday in the exam. Yes.